Since the late 1980s, Michigan State University biologist Richard Lenski has been running a long-term evolution experiment with E. coli bacteria. A staunch supporter of Darwinian evolution, Lenski wanted to follow a population of bacteria over time and see what new functions would evolve.
I'm a big fan of this experiment because it does not put out a model. It's not a computer model. It's not a theory. What he did was let evolution happen on its own and say, what did it do?
By 2014, Lenski and his researchers had grown over 60,000 generations of bacteria.
That's equivalent to, say, a million years in the lifespan of a large animal like us. And there have been trillions upon trillions of different bacteria that have been born and died in his flasks.
Although often cited as providing evidence for Darwin's theory, Lenski's experiments are perhaps most revealing in what they haven't produced.
We don't find a new protein with a new fold with a new function. By and large, these are deletions, insertions, rearrangements of information that's already present.
He didn't see anything like the evolution of some new complex system like the flagellum. Nothing remotely like that.
At some point, you're going to have to show that you have a gene with one function has now evolved into a gene with a different function, different protein folds, and we're still waiting.
What we see going on in the Lenski laboratory and other places too is that Darwinian processes or random processes degrade information. They do not build it. They are not putting in new information. They might tweak something here or there, and at the margins you can have differences about what you call information.
Taken together, this flood of new data has raised a powerful challenge to claims that natural selection can explain the origin of new functional genes and proteins, let alone a complex biological machine like the flagellum. At the same time, new hurdles to the Darwinian mechanism are also being raised that are specific to evolutionary accounts of the flagellum itself. For example, evidence has continued to accumulate that the type 3 secretion needle complex was not a precursor to the flagellum after all.
The flagellum definitely came first.
Mutation density studies show that genes in bacterial flagella have experienced more mutations than genes in type 3 secretion needle complexes. Genes that have experienced more mutations are generally presumed to be older.
We find flagella across all phyla of eubacteria, very deep. The mutational densities are great for bacterial flagella. We find them arranged in the same genetic arrangements on the chromosome across genera, across families. For the most part, there's been some rearrangement. It was part of the aboriginal chromosome of these organisms. In contrast, type 3 secretory systems, we find in a very narrow range of gram-negative bacteria. They've been imported, and the mutational densities are much shallower, which means they're newer structures compared to the flagella.
The supposed killer explanation against Behe has turned out to be a dud. The needle complex can't explain the evolution of the flagellum because it didn't even exist until after the flagellum. But there's more. Darwinian explanations of the flagellum assume that parts already existed that natural selection could reuse in order to build the flagellum. This may well explain some features of the flagellum, but there's a big problem. Key flagella parts are turning out to be unique. They don't appear to exist anywhere else. They are only found in the flagellum, and if they didn't exist already, natural selection wouldn't be able to use them to build something else. Even if all the necessary parts were there for natural selection to co-opt, it's now becoming evident that just having the parts alone wouldn't be sufficient. Complex structures almost always require a specific sequence of assembly. When building a house, a foundation must be laid before the frame can be put up, and the frame must be completed before the roof can be added. In a similar way, a flagellum must be built in a carefully orchestrated process that is governed by assembly instructions encoded in the DNA. Merely having the various parts of the flagellum available in the vicinity of a bacterium isn't enough.
Even if you had just floating around a type 3 secretory system or a hook protein or a rotor or a drive shaft, you've got to put these things together. And biological systems aren't put together like Lego bricks. You don't just stick them together. There's a very precise sequence of expression of these genes, these protein products, that allows the machine to be built piece by piece, somewhat like the assembly apparatus in an automobile factory. That assembly routine, involving multiple different genes and regulatory proteins, is itself arguably an irreducibly complex system. You remove any one of those genes or one of those regulatory proteins, the flagellum is simply not going to get built. Something will shut down the biosynthetic pathway if one of those key elements is missing. So co-option, in an attempt to get around the irreducible complexity of the finished product, posits a bunch of parts which could only be plausibly put together by another irreducibly complex system, so you haven't really solved the problem.
The existence of assembly instructions required to build a flagellum isn't simply a challenge to Darwinian evolution. It also provides evidence of intelligent design. Encoding the assembly instructions requires massive amounts of biological information. But where does that biological information come from?
The genome is full of information. It has literally a sequence of DNA letters which tell the machinery of the cell what to make. It's like a blueprint.
We know of a cause that can produce digital code, hierarchically organized information, integrated circuitry, and that cause is intelligence. In fact, that's the only known cause that we know of, based on our uniform and repeated experience, the basis of all scientific reasoning about the past, that we do know of that can produce information, and therefore it is possible to infer from those effects information processing circuitry back to intelligence as the best causal explanation of those complex molecular machines.
More than 2 decades after the publication of Darwin's Black Box, the challenges to Darwinian explanations of molecular machines like the flagellum have become even more daunting. As a result, evolutionary biologists are scrambling to find new unguided mechanisms in order to avoid facing the alternative proposed by Behe and others, that biological systems reflect intelligent design. Michael Behe raised ideas that even now are reshaping how we understand biological systems. The man who describes himself as shy helped spark a revolution.
Well, one of the things I like about Mike Behe is that he's a very humble and unassuming guy. He's not full of himself, yet he's a player on the world stage scientifically. People all over the world know of his idea of irreducible complexity. They know of the idea of intelligent design because of his work. And it's really reframed the debate. Whether you agree or disagree, one way or another, you've got to now address the question of the origin of these irreducibly complex systems that we find in living systems, whether we're talking about the flagellar motor or the ATP synthase or the kinesin walking motor protein or the circuitry or the gene expression system or whatever it is. The biology inside the box is really complex, and it's an integrated and functional complexity that requires some kind of an explanation. And I think just by highlighting that, Mike has reframed the debate in a way that I think has changed the way people think about biology in the 21st century.
For Behe, the most satisfying part of his intellectual journey isn't getting recognition, it's opening minds.
I remember in particular a time I was talking at the University of Massachusetts at Amherst, and also on the stage and also talking, it was not really a debate, but a kind of a different perspectives on issues, was a lady named Lynn Margulis, who was a very prominent biologist, a member of the National Academy of Sciences. And there were about 1,000 students in the audience. There was reporters from the New York Times, the president of the university was there. It was great. And after discussing it, I had a number of students come up saying exactly that they hadn't thought about it from this perspective before, They thought either that you had to be for evolution, quote unquote, or for creation, quote unquote, or that, you couldn't have scientific reasons for being skeptical of Darwin's theory. And they kind of scratch their heads and say, I'll have to think about that. And that's the moments that a teacher like myself just lives for.